Okay. It can be an open or a closed sketch like this. Okay. What will happen if I extrude this thing? Okay. Then we have something called a revolve. I think you know what is the purpose of revolve. What does it do? It's about an axis. It revolves around an axis, right? Yes. We said about that, right? We can use even this axis or this axis. Uh, in partisan, you see, I'm just revolving this thing. You see, just right click on this thing and use our axis. It is our Z axis which is passing through the center. This one, you asked this one, right? Okay, yes, we can do that. No, drawing and center line is not a, mandatory. That's according to our need. We can adjust. Okay. Then we have extrude, revolve, then spear. The way to use spear is that it is one easy way to draw our easy way to draw our what uh, a spherical shape. Any easy way to draw a spherical shape. Okay. For that, what we need is a center line and a center and a center. I'm using this origin, I can put a hole there under the sketch. There's a hole which I just made on the center portion of this thing, this geometry. And either we can specify here the wall sphere and specify the radius, or just the create sphere by specifying angles and mention the angle. Okay, angle by means it's parallel start, parallel ends, meridian start. Okay, what you are asking? Sure. We can create under revolve. How? But we have to exactly draw the dimensions. If we have to draw something like that, we have to exactly match the dimensions in such a way that I'm just drawing here itself so that it is visible. It can be compared. I am just giving some distance and so that it's defined. Okay, I'm using a 3 point arc or center arc. You see here, but I have to specify the angles from here to here and all like this. This is meridian end. This is meridian start. Sorry, parallel end and parallel start. These angles, right? You see these things. Parallel end, parallel start. Meridian end and meridian start is the rotation. This is parallel ends. If I want the same angle, which is 48, and it is 30, 50, 30. Okay, that's the thing. Okay, this is. 50, right? Or 30? 50, 30. Then we have to see this radius. What is the radius? 25. Okay. Then the angle of revolution, it is, I'm making this as 0 and this as 120. Okay. That means I have to rotate about this axis. Exit. You see, it is automatically dictating this center line. But I don't need that one. I need this one. Okay. If the case is like that, uh, just I drag and place my compass here. Let me try about UVW. That means it is X, right? Axis as this one. Um, yes, axis as X and this one. Oh no, it is taking only this axis. So if in this case, try drawing a center line here. Okay. So automatically that will be dictated as the, and instead of this thing, use construction line. Good idea. Even though both look alike, there are some difference in usage and all. I think you got the difference from appearance itself. I mean, not the spear. About I was talking about the dotted line. Dotted line. You see, it is axis. It is construction geometry. Both are different. You understand? Coincidence. Okay. Then I'm making this and this thing. These two coincidence. Coincidence. And it has this point coincident about this axis. Exit. Revolve. Now it automatically took to this one. Not this one. This is 0 and this is 120. Okay. These are the same things. Yes. 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 Here these are by default these are there. Okay. There is also one more sphere in which the wall, if you are going to this thing, the wall sphere will be created. Whole sphere will be created. Okay. Then we have something called a cylinder. For cylinder, there are a couple of things which we have to mention. That is the axis and the starting point. Point and direction as this one, and we can control the length. Understood? Then we have offset tool. Here, nothing but mention the direction, offset distance, and if you have to reverse it. Okay, if both side, it will be created in both the sides. Okay, that is offset. Then we have sweep tool, fill and multi-section blends. I will show sweep. Now before sweep, I will show you fill first. Sweep is a bit long tool. Okay, there are some sub options there. I will show you that. The fill is nothing. We have to specify a closed region. If it a closed counter, it will automatically fill the region. Understood? You see, say no. That will be in surface only. For making it into solid mode, that's better. It is good you asked. You see, we have to use this tool. It is closed surface. I'm checking closed surface and selecting this surface. Even without this filled part, it will be converted into a solid. Okay, even without that fill. Understood. And after the use, just hide this part, hide this cylinder and that part. We will get the cylinder. Okay, understood. And do you remember our the other tool? And going back to my wireframe and surface design, and there was one reference tool, right? Reference reference plane. We created reference plane, reference plane and all. No, under part design. Ah, reference elements. Refer, do you remember this tool for creating reference geometry? This tool. Ah, ah, yes. Under wireframe and surface design, that reference tool is under wireframe itself. Okay. There are a little bit more options there. We will be seeing it that when we come to the wireframe session. Uh, you see, here there's a line tool. I'm just using that line tool and connecting this point and this point. Okay, that is covered into one part. Okay. Then you see I'm using fill. Under fill, I'm selecting this curve and this line. After selecting that too, it is a closed region. I can make it into a closed region like this. Understood? In this way, we can use our fill tool. Then we have multi-section surface. Multi-section surface is everything is same as our multi-section solid. Do you remember multi-section solid? Yes, right, exactly. Not something like boundary, exactly same as boundary. The same thing as boundary. Okay. Here we have multi-section surface. Uh, for that, what we need is two curves, not just it can. Sorry, it is anything. Yes, two different geometry. The number of vertices has to be matched. Otherwise, we know there will be some problems, and also I think we know how to solve that problems. Vertices option and all under multi-section. Remember these options. This option vertices and all. Right? If the number of vertices are not matching. Mm. Yes, yes. You see, this is the way multi-section curve will be working. Just connect to. connect to curves. It can be open curve or closed curve. Okay, no issue. The curves can be opened or closed. I haven't tried such a figure. Let's try. Let's try multi-section one, two. Make sure that the arrows are in the same direction and all. And section one, section two. Okay, arrows are pointing in almost good. Okay, there is no problem. You see, I don't want to like these things and all. How can I avoid that? No, with using this, no, with using this tangency, I think tangency won't work here. I think tangency will also be doing, but without tangency, you see, when I use tangency, there are some other things are happening. Do you notice? These are not straight. There will be some curves and all. There will be some curved portions here. There is some one option for tangency and curvature that will make some adjustments here. Or if you have to, we have to select our own vertices. Use this vertices option. Okay, use this vertices option. Select this thing and connect with the closing point. Where is closing point one and closing? Make sure that we are connecting to the right portion. Always start from one to two. Okay, I am removing this section from this is section one. This is two. From here to here. You see, if I have to, I can make the control. Okay, every coupling is in my control. That is in that's in which option? Vertices option. Okay, this is multi-section, and then we have some other. It is a very interesting tool, blend. Uh, blend means while in SolidWorks and all, we used to connect some different parts by using guide curve and all, right? You see, this is in a way it is acting as a loft. I mean, multi-section surface, but there will be small difference, and I will show you. Let me consider two. So did you ask anything? Normal to profile and all. Normal to profile, similar to that. I'm just moving parallel. I'm sketching here. Okay. Okay, Vishal. Okay. Okay, you see, I have drawn two sketches, two parts like this. What I'm now doing is I'm just hiding these sketches. Uh, there is no issue. Even with that sketch, it will work. but I just hide it so that it is there is no sketch there. Okay. You see, there's an option called blend, and the options which they ask is first curve, first support, second curve, second support. As the first curve, I'm selecting this edge, and as the first support, I'm selecting this one, and as the second curve, I'm selecting this edge, and as the second support, I'm selecting this one. Then I'm giving a preview. You see, this will be connected like this. There is a continuity there. You see, first continuity. If I'm changing that to points, it will be connecting like this. If I'm changing both the second continuity to points, it will be like this. Okay. If I have to follow the tangency of this plane, move to tangency. The first one is following the tangency of this plane. And the second one, if I have to follow the tangency, just give tangency here also. But in this case, tangency and curvature both will be acting in a manner same. Okay. Okay. So it will be extremely useful when connecting two parts in CATIA while giving while modeling some things like this. It's also possible with the two open profiles also. Okay, not just a glass close, not just with the closed figures like this. With the open profile also this will work. But it has to be some surface. Okay, there has to be some surface. Otherwise, from where it will find the tangency, curvature, and all. Okay, if I have to connect these two things, go to blends, select first curve, first support, second curve, second support. You see, that's connecting from one to another. And also the tangency is followed. Okay, this is blended too. Understood. Then we will sweep tool. We haven't set it right. Under sweep, what is the purpose of sweep? I am sure you know. Then also still asking. What is swept? You're almost there, but I want a more generalized answer. More. Now you are concentrating only on one of the application. No, no, no. It's following a cross section following a path, right? That path can be spiral. Yes, it can be a spiral, or it's not necessarily a spiral. Spiral. Okay. No, nothing. Why, why? Are you talking in general for CATIA? In general, the surface, the accuracy will be more for CATIA compared to any other software. Okay, but that has nothing to do with the sweep tool. In general, it will be more for CATIA. You see, I will be showing one of the application of the sweep. In sweep, there is an option called you see profile type. There are different types are there. First one it is explicit. Under explicit, what it does is we can select a profile and a guide curve. As the profile, I'm selecting this one, and as the guide curve, I'm selecting this one. You see, and I'm giving a preview. You see, it's making a sweep from here to here. Do you remember this tool? This kind of tool which we did in SolidWorks. Ah, right, right, right. That is called rib, right? I'm creating two planes here, and normal to profile, normal to profile, normal to curve. Sorry, normal to curve. Okay, and I'm just offsetting this thing, offsetting this plane, keeping it here. Okay. And I'm using the same sweep again. Sweep. Uh, this is the usage option which you are using explicit, and as the profile, I'm saying this one, and as the guide curve, I'm saying selecting this one. Preview. You see, there are two planes which I have created. I can use that as a relimiter. You see, here there's an option called a relimiter. And as the first relimiter, I'm using this thing. And as the second relimiter, if I want, I can use this thing. Preview. You see, it will be creating only up to the portion which we have done or the plane which we have shown as the relimiter. And there is also one option called a spine. Can you see this one? Spine, spine. Ah. Spine is nothing but no, 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 no. You see, the sweep may not be hello. The guide curve is not necessarily passing through the center. Okay, but the spline will be always passing to the center of the object. That's the thing. Okay. 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 I thought he. I thought you asked the second time. Please say it again. Okay. 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 You take your time. There were we actually. I think. Ah, yes. And relimiter and whatever I was saying, the difference between spine and guide curve. Okay, spine should be always through the center of the sketch, but the guide curve is not always to the center of the sketch. That's the only difference. Okay. Okay, here okay, there are some other options on the line, sorry, on the sweep. I think we will see that tomorrow. Okay, we are stopping for now. Just practice this tool, okay? Except the spine, sorry, sweep. We will start from sweep tomorrow because that's better.